Prior to discussing the announcement, it is essential to comprehend what particle accelerators are. The Large Hadron Collider (LHC), which CERN runs, is a 17-mile-long superconducting magnet ring, as well as the largest and most powerful particle accelerator. It symbolizes the highest level of human scientific achievement. In fact, it's so powerful that it can recreate the very conditions of the universe's birth. But could this apparatus be used to unlock the secrets of the universe, or hold the key to something far more ominous? CERN, established in 1954, is one of the most reputable research institutions, with 23 nations as members. It serves as a hub for thousands of scientists to work together, and CERN's flagship project is the LHC, but it's just one part of a vast network of accelerators and experiments. Imagine a racetrack, not for horses or automobiles, but for subatomic particles in a race against time. In the LHC, protons are accelerated in space itself to send them nearly at the speed of light, colliding in a way that mimics the universe's energy at the time of the Big Bang. The collisions create temperatures that are 1 million times hotter than the core of the sun. Thousands of magnets guide the protons on their journey, while complex cooling systems maintain temperatures below those of outer space. The beams inside the LHC are made to collide at 4 locations around the accelerator ring, corresponding to the positions of 4 particle detectors: ATLAS, CMS, ALICE, and LHCb. Each serves a unique purpose, exploring different aspects of particle physics. Together, they act as colossal cameras, capturing snapshots of these collisions. Scientists then sift through the debris, looking for signs of the elusive Higgs boson. It's also known as the God particle, and other phenomena that offer clues to the universe's fundamental building blocks. By studying the microcosm, we gain insights into the macro. But with each response, there is a new question, and with every discovery, a new challenge. The LHC is not just a scientific instrument. It's a testament to human curiosity and innovation. It embodies our relentless pursuit of knowledge and our desire to understand the fundamental forces that shape our universe. Yet as we push the limits of our knowledge, we must also consider the ethical and existential concerns that arise, including the dangers of probing the unknown. Could our quest for understanding inadvertently unlock forces we cannot control? In the hallowed halls of CERN, where the boundaries of human understanding are constantly pushed, a new revelation has come to light that sends a shiver down the spine of even the most seasoned scientists. Brian Cox, former CERN researcher and an authority in the particle physics world, has recently made an announcement that has left the world both fascinated and fearful. Cox's words convey the goal with haunting clarity. The Large Hadron Collider at CERN is to recreate a mini Big Bang. Yes, you heard that right, a miniature version of the very event that led to our universe. The physicist also enumerated the ramifications of this objective, highlighting the LHC's extraordinary potential for making new discoveries. This includes its ability to unlock the secrets of the Higgs boson and explore dark matter, a mysterious substance that is a significant component of the universe. Imagine holding the power to conjure the very essence of the universe in your hands. It's a tantalizing prospect, but one fraught with danger. The mini Big Bang is not just a theoretical concept. It's a tangible reality within the LHC. The temperatures, pressures, and raw energy all mimic the conditions of the universe at the beginning of time, the birth of existence itself. But with such power comes responsibility, and the question looms: what if something goes wrong? In fact, something did go terribly wrong. Anatoly Bugorsky, a Russian physicist, experienced a disaster in 1978 that would forever alter the course of his life while working on the U-70 synchrotron at the Protino High Energy Physics Institute in Russia. A malfunction led to his head accidentally coming into the direct path of a proton beam. The forceful beam, beyond comprehension, traveled through his skull, entering the back of his head and exiting through his nose. Bugorsky's experience was unlike any other. He saw a flash brighter than 1,000 suns, but felt no pain. The beam's path left a trail of destruction, burning through tissue and bone. Yet astonishingly, Bugorsky remained conscious and even walked to the hospital for treatment. The result was both horrifying and fascinating. The beam's path caused localized tissue death, leading to the loss of hearing in one ear and partial facial paralysis. Yet, astonishingly, Bogorsky's intellectual capabilities remained intact, and he continued his scientific career. This incident is not just a personal tragedy, but a cautionary example that highlights the immense power and potential dangers of particle accelerators. Particle accelerators like the LHC are not to be taken lightly. Potential for unforeseen reactions. The very fabric of space and time being manipulated, these are not the stuff of science fiction, but real concerns voiced by some in the scientific community. One of the most troubling and intriguing issues associated with these experiments is the possibility of creating a miniature black hole. A black hole is an area of space-time where gravity is so strong that not even light can escape. They are cosmic vacuum cleaners, devourers of stars, mysterious entities that lurk in the shadows of our universe. The idea that such an entity could be created by the LHC, even on a microscopic scale, is shocking to both the general public and experts alike. Could this black hole grow uncontrollably, consuming the planet from within? Those scientists at CERN have assured that any black hole created would be unstable and evaporate almost instantly. The mere possibility has ignited debates, fears, and a sense of awe at the power we wield. It's important to understand how the LHC could create a black hole. It has to do with the fundamental mechanics of particle accelerators. When protons are smashed together at nearly the speed of light, the energy released is so immense that it alters the structure of space-time itself. Imagine a trampoline stretched tight, and then a significant weight is dropped onto it. The fabric bends and curves, and if the weight is heavy enough, it could create a depression so deep that anything nearby would be drawn into it. That's a crude illustration of what could happen in the LHC, in the world of quantum physics, where the rules of the universe are as beautiful as they are bizarre. There exists a theory that extra dimensions may be hidden within our reality. If these dimensions exist, the LHC's collisions could tap into them, creating a gravitational funnel that forms a microscopic black hole. This enigmatic dance of particles has even caught the attention of some world-famous scientists, particularly the late Stephen Hawking. In his book, he warned of a scenario where the Higgs boson could become unstable at very high energy. This instability could result in a catastrophic vacuum decay, a cosmic event that would not only endanger the planet but the entire universe itself. The esteemed British cosmologist and astrophysicist Sir Martin Rees also expressed his concerns about the experiments conducted at CERN. In his book, On the Future Prospects for Humanity, he investigated the potential dangers associated with particle accelerator experiments, including those carried out at CERN. His words were not merely cautionary. They were infused with an existential tinge of dread. He predicted the worst-case scenario, where an ill-fated experiment could create a condition called vacuum instability. This instability could, in theory, trigger a phase transition that would ripple through the very fabric of space-time, resulting in a cosmic catastrophe that could engulf the entire universe. Rees's concerns were not limited to theoretical musings. He assigned a probability to these catastrophic outcomes, albeit a low one. But even a minuscule chance, he argued, should give us pause. The stakes are unimaginably high, and the margin for error is razor-thin. Scientists at CERN have calculated the odds, run simulations, and examined theories to argue for the safety of the LHC. In fact, Brian Cox himself acknowledged the importance of responsible investigation, recognizing there are a lot of worries and fears pertaining to the LHC's activities. He emphasized that rigorous, extensive safety measures, reviews, and protocols ensure the LHC's operations are conducted with the utmost care. Cox reassured that the energies involved are well within what the Earth naturally encounters, and the chances of creating a stable black hole are astronomically low. Even if one were created, scientists say it would be so tiny and so unstable that it would disappear in a flurry of energy, a phenomenon that Stephen Hawking predicted would be known as Hawking radiation, a fleeting moment of cosmic wonder, a glimpse into the abyss, and then gone. Some have gone further, speculating that the LHC's experiments could open a portal to another universe or dimension. This notion, though largely dismissed by the scientific community, has successfully captured the thoughts of many people and has evolved into a subject of fascination, fear, and even folklore describing the world beyond ours. Could we inadvertently unleash forces or entities that we are unable to comprehend? The idea of opening a portal to hell has even been sensationalized in various media, adding fuel to the fire of uncertainty. But how did this idea come to be, and what does it mean in the context of scientific exploration? The concept of parallel dimensions is not new in physics. String theory, a leading candidate for a single theory of everything, posits that there may be more dimensions than the usual three of space and one of time. These additional dimensions could be reduced to a smaller size or hidden from public view, but they could theoretically be accessed or exposed in extreme circumstances. Imagine the LHC as a key to the cosmos, unlocking sealed doors since the dawn of time. When protons collide at energies never before achieved on Earth, they could, in theory, reveal hidden dimensions or create bizarre new phenomena. In this sense, the LHC transforms into a vehicle for humanity's curiosity, pushing the boundaries of what we are aware of, seeking answers to questions we didn't even know to ask. As we begin this journey of discovery, one thing is certain: the consequences of our actions are extensive, and the pursuit of knowledge comes with both wonder and risk. While scientists strive to unravel the most mysterious aspects of our existence, we must also remember that with great power comes great responsibility. As the pursuit of knowledge through the LHC continues to increase the stakes, the deeper we venture into the mysteries of the universe, the more we confront the unknown. And with that unknown comes a profound obligation. Science has always been motivated by the search for understanding, the desire to learn the truths of existence, to reveal the fundamental building blocks that make up everything we see, touch, and experience. But each revelation often leads to more questions, more complexities, and more unknowns that call for investigation. The LHC has immense potential, but it is not merely a machine that speeds up particles. It is a bridge to the deepest mysteries of nature, providing us with a window into the very heart of the universe. The findings that have already been made, such as the confirmation of the Higgs boson in 2012, are monumental. They confirm the existence of particles predicted by theories decades before, strengthening the standard model of particle physics. But even more exciting are the frontiers that remain uncharted. The LHC has the potential to reveal insights into dark matter, the mysterious substance that makes up most of the universe's mass, but remains undetectable by conventional means. It might even provide the key to understanding dark energy, the mysterious force accelerating the expansion of the universe. Yet, scientists push the boundaries of knowledge. They must also recognize the limits of their understanding. The LHC's potential for discovery is unparalleled, but with it comes the risk of unintended consequences. Each experiment conducted at CERN is an exploration into the unknown. And in such a vast and intricate field, there are always risks of outcomes that could be unpredictable. Despite the rigorous safety measures and decades of preparation, there's always a possibility that something unforeseen could occur. Something that might challenge not only our understanding of physics, but our very existence. For all its potential dangers, however, the LHC is a testament to human ingenuity and determination. The sheer scale and ambition of the project are a reflection of humanity's desire to reach beyond the confines of the known world. To venture into the deepest recesses of space and time serves as a reminder that the desire for knowledge, while fraught with uncertainty, has been the engine of human progress for centuries. It is that curiosity, that relentless pursuit of truth, that has brought us to this point, where we stand on the precipice of some of the most profound discoveries in human history. As the LHC's operations continue, the world will be watching closely. It's not just scientists who are fascinated. People from all walks of life are captivated by the potential to unravel the mysteries of the universe. The LHC has sparked discussions, debates, and even fears about what could be discovered. Many see it as a symbol of hope, a tool that can lead us to a deeper understanding of the cosmos and our place within it. Others view it with trepidation over the potential dangers and threats that could accompany such powerful experiments. As with all major scientific endeavors, the LHC represents a delicate balance between ambition and caution. It is a powerful instrument that opens up new realms of knowledge, but it also requires careful consideration of the potential consequences. Scientists at CERN are acutely aware of these risks and work with the utmost diligence. Yet the very nature of their work forces them to acknowledge that science does not provide assurances, only possibilities, probabilities, and a constant pursuit of understanding. In the end, the LHC will continue to be a beacon of exploration. It is more than just a machine. It is a symbol of humanity's unwavering search for truth. But as we explore the vast undiscovered, we must remember that with every discovery, we may also uncover new challenges, new uncertainties, and new responsibilities. The pursuit of knowledge is a journey, and like all journeys, it is fraught with both wonder and danger. As we stand on the cusp of a new era of discovery, we must ask ourselves, are we prepared for what we might find? What lies ahead in the present and future of particle physics and the LHC's experiments is as enigmatic as the questions it aims to answer. One thing is certain: the discoveries that emerge from this cutting-edge research will shape our understanding of the universe for generations to come. The LHC, as it continues its work, is not just a scientific experiment. It is a testament to humanity's curiosity, its resilience, and its unwavering drive to explore the unknown. Whatever the outcomes may be, the journey itself will leave an indelible mark on the fabric of human knowledge.